Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the today's question. It's a nice problem on the topic of definite integration. It says the greatest integer less than or equal to integral 1 to 2 log of x cube plus 1 to the base 2 dx plus integral 1 to log 9 base 2 2 to the power x minus 1 whole power 1 upon 3 dx is. Now students, the best way to solve this problem is if we find the relation between these two functions. You can evaluate these two definite integrals separately also. But if you find the relationship between these two functions, the question will become simpler. Now for this purpose, I am supposing y equal to f of x equal to the function log of x cube plus 1 to the base 2. Now from here I can write 2 to the power y equal to x cube plus 1, or x cube is equal to 2 to the power y minus 1. So I can say x is equal to 2 to the power y minus 1 whole power 1 upon 3. Now students, since y is equal to f of x, so I can say that x is equal to f inverse y. Right? Now just replace y by x in this equation. So you will get f inverse x equal to 2 to the power x minus 1 whole power 1 upon 3. That means if this function is f of x, then the function inside the second integral is f inverse x. Fine. Now students, the expression becomes integral 1 to 2 f of x dx plus integral 1 to log of 9 base 2, and inside the integral we have f inverse x dx. Now I will simplify the second integral. I will put f inverse x equal to t. Now from here I can say x is equal to f of t. So I can say dx is equal to f dash t dt. I have just differentiated both sides of this equation with respect to t. Now students, we move further. Now students, the expression becomes 1 to 2 f of x dx plus integral. Now since we have done substitution in the second integral, so the limits will also change, and now the limits will be 1 to 2, because when x is equal to 1, then the value of t also comes as 1, and when the value of x is log of 9 base 2, then the value of t comes as 2. And inside the integral, now we have t, and in place of dx I will put f dash t dt. Right? Now students, to solve this particular integral, we will use integration by parts. Now this expression becomes integral 1 to 2 f of x dx plus. Now I am going to find the value of the second integral by integration by parts. So I will call this function as second function and this function as first function. Now it becomes first function into integral of second function, which is t into f of t, minus integral derivative of first function, which is just 1, into integral of second function, which is f of t dt, and limits are from 1 to 2. Right? Now students, this becomes integral 1 to 2 f of x dx plus, here it becomes 2 f of 2 minus f of 1, and this is nothing but 1 to 2. Students, we know that in definite integral, the name of variable does not affect the value of the integral. So I'm just replacing t by x. So now it can be written as f of x dx. Now this integral and this integral will cancel each other. So the answer becomes 2f of 2 minus f of 1. Now students, we find the final value of the expression. Now students, f of x is equal to log of x cube plus 1 to the base 2. So I can write f of 2 equal to log of 8 plus 1, which is 9, to the base 2. And similarly, I can write f of 1 equal to log of 2 to the base 2, which is nothing but 1. So now I can say the value of the expression, that is 2 times f of 2 minus f of 1, can further be written as 2 times log of 9 base 2 minus 1. But we have to find the greatest integer less than or equal to this value. And for this purpose, I am writing 9 greater than 2 cube, because we know that 2 cube is 8. And 9 can be written smaller than 2 to the power 7 by 2. Now, 2 to the power 7 by 2 is nothing but square root of 128. And square root of 128 is obviously greater than 11, which is further greater than 9. Now, what is the advantage of doing this? Now students, we know that logarithmic function log x to the base 2 is an increasing function. Because whenever the base of log x is greater than 1, then it is an increasing function. So now I can write log 9 base 2 will be greater than log 8 base 2, which is nothing but 3, and smaller than log 2 to the power 7 by 2 to the base 2, which is nothing but 7 by 2. Now students, just multiply this inequality with 2 throughout. So you will get 6 less than 2 times log of 9 base 2 less than 7. Now if I subtract 1 throughout this inequality, I will be getting 2 times log 9 base 2 minus 1 greater than 5 but smaller than 6. So finally, I can say the greatest integer smaller than or equal to this value is nothing but 5. So that means 5 is the correct answer. Now students, next question I will be posting in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.